Right, so electron structure. So this is, as chemists, we get excited by electrons, really, because they are the guys that do the biz for us. But before we get into the exciting stuff, we need to do a few definitions, which you are going to know, because the first one is the first ionization energy. What is the first ionization energy?
The amount of energy required to move one electron from one mole of gaseous atoms to produce one mole of gaseous isotopes.
One electron from each atom in a mole of gaseous atoms. And often they'll ask you to give an example. And some people say, because often it's just, oh, this is an example of X. Don't do that. So let's do it on magnesium. Mg gas goes to Mg plus gas plus an electron. Okay. Second ionization energy is obviously just going to remove the next electron, like so. So it'd be taking Mg plus gas, go to Mg2 plus gas plus an electron. And you can carry on. So the way to remember it, second refers to making a 2 plus ion. What we're interested in is the first ionization energy. So I'm sure remember, if we did it for, well, and carrying on, so looking, first one first, but then looking at successive ionization energy. So if we took magnesium and we plotted for magnesium, removing electron at a time, what would it look like? So we would call this, so this is going to be ionization energy, and this is your ionization energy number. So successive ionization.
The first two will be very easy to remove.
Yeah.
And then after that it'll be harder. Then it gets easier again when it gets sharper.
Okay, well, let's have a think. So let's do GCSE. What's the electronic configuration of magnesium? It's going to be 2 in the first, then 8, and then 2.
Yeah.
When I'm going to remove, the first one's going to be, which 2 am I removing?
The first two. The last two.
These ones.
Yeah.
These are the ones that go first. If you draw your little magnesium atom.
Yeah, sorry, I'm just.
No. So you've got a well-dodged diagram.
Yeah, nice.
Like so. Those are the guys that go in first. So those 2 are easy. But getting harder. Why is it getting harder?
Because it's.
I removed that one. Why is it harder?
It's a full shell. It doesn't want to do. Because the
I
proton
removed that.
hasn't removed.
What now has my magnesium got? What is now got?
A higher charge.
It's got a positive charge, hasn't it?
Yeah, higher charge than its proportion of electrons.
The first one refers to that. The second one refers to Mg plus gas going to Mg2 plus gas
So it's going to
plus.
pull the electron in.
So I'm pulling an electron away from a positive ion. Negative electron, positive ion, going to attract.
It's great attraction.
Yeah, much harder to do it. You can also argue that you've got the same number of protons attracting fewer electrons because you already removed them. So first 2. Then, so those 2 have gone. Then we've got the 8, and you see a big jump. So 1, they still get harder. 1, 2, 3, 4, 5, 6, 7, 8. So those are the 8 there, and then so those have gone.
Then another jump.
Yeah, brilliant. And then I get another jump like so. So what does this give me evidence for? This shells. This gives me evidence for the Bohr model of the atom, where we have shells of electrons.
Do you not have to look at the P and the S orbitals for this?
Not for this, no, because the energy difference between the P and the S is so small, it doesn't. I mean, these are massive. This is often on a logarithmic scale, so you don't, because they're massive energy changes. So it does shrink it. So it shows you the trend without you taking a massive page of graph paper to do it. So that gives me energies. Now, if you check out periodicity, we look at the factors that affect the ionization energy. But let's just recap. If I now plot let's go across period 2. What happens, so this, I'm going to plot now the first ionization energy for various elements. So let's put it in atomic number, or the atoms going on here. What's going to happen? I'm going to start off with lithium. So I've got lithium, beryllium, boron, carbon.
Is this one that looks like a bar chart? The 3 are increasing.
What's a general trend? What happens? Lithium,
Yeah, a little bit higher, and then
beryllium,
a little bit higher,
boron.
and then a big spike up, isn't it?
Well, it's just generally getting harder. Why is it getting harder?
Because
It's less, more electrons in the outer shell.
Ooh, okay.
increasing
What am
proton
I?
number.
I've got more.
There's
Protons.
more protons, so
I've got to consider atomic number.
like a greater nuclear attraction.
I have to think about shielding,
Oh yeah, the radius.
and I have to think about atomic radius.
The radius
Decreases, so it's good tighter.
What's happening to my atomic number across the
increases.
that increases, so that's going to, so I've got more protons. What happens to my shielding?
Same.
I know, yeah, same. It's
The same number of inner electrons, so that's the same. So what's going to happen to my atomic radius?
Decreases.
That gets smaller. So what's going to happen to the attraction between the outer electrons and the nucleus? It's going to increase, so that's why I see my general increase across A. But we do far more than that when we look at periodicity, so we won't worry too much. But remember, shielding only thinks about the inner electrons.
Just shells.
Yeah, just the inner shell. So for lithium, those two are shielding electrons. The same when I go to beryllium, those two are shielding. Why can't he shield him?
Because he's in the same shell.
Yeah, so, yeah, because if you think about it,
Same.
I kind of think about it as like being a party, that there's your attraction, there's the person that you quite fancy, this is you, that's your friend, because you're stood next to each other, you're chatting with your friend, blah de blah de blah, but they're not getting in your way of seeing the attractive person. Okay, these people are getting, they're shielding you and getting in your way.
Good
So
explanation.
these guys don't. So anybody around here, they're not getting in your way, but these guys are stopping you being attracted to the
Chemistry
person.
of dating.